In this video, we're going to look at what is called variance inflation factor. Now, VIF. VIF is a measure that measures the multicollinearity contribution of a particular predictor variable. Now, this is how it works. Okay, multicollinearity is the correlation among the predictor variables. So one way of measuring that is to take one of the x variables, right? Treat that as the y variable in a regression. Okay, and treat that as y and treat all the other x variables as independent variables and run a regression and see what the coefficient determination r squared is. So higher the r squared, more highly correlated this particular x is with all the other x's. Okay, and then you compute 1 over 1 minus r squared. Then what you get is VIF, and higher the VIF, the more multicollinear that particular predictor variable is. Just think about it. Suppose if it has perfect correlation, if given x is perfect regression with the rest of the x's, so you will get an r squared of 1. Okay, r squared is a value between 0 and 1, 0 being no regression at all, and 1 being perfect, right? So if it has perfect regression, then you will end up with 1 over 1 minus 1. So that will be infinite, undefined infinity, very, very large number. But if it is completely unrelated, you'll get a 0 for r squared, then VIF will be value 1. So value 1 is really good, and larger values means it has high multicollinearity factor. So this is another way of expressing the same thing. So let's see how this is calculated. So here MED-V and cat MED-V are the targets. So let's look at the rest of them. Okay, for each of these x variables we can compute a VIF. So let's say we want to first find r squared. Okay, so this is, let's say we are trying to find the VIF for CRIM, right? So now we need to find the r squared value with CRIM being the y variable and the rest of the x's being the x variable. Now I have set up a macro function that does that without having to run the regression, and that's that. Then we have to first provide the y value. So we're going to use CRIM as the y variable, right? And then the rest of them back up, okay, up to LSTAT. So the rest of them as the x variable. So then you get an r squared value. So then VIF is 1 over 1 minus r squared. So you get a value of 1.79, which is okay. R squared is not very high. Okay, so then you repeat. So next one is ZN. Now you find so you need to repeat the next one, use that as y and the rest of them as x's. You find the r squared and find the VIF, and then you use that one as y and the rest as x's and find VIF, and so on. And now you can set a threshold like 4 is a good threshold. Anything over 4 is problematic, or anything over 5, 6 is problematic. So let's try some values here. Okay, if r squared is say 0.5, then you see VIF is 2. If r squared is 0.8, so then you get 5. Okay. If r squared is 0.9, you get the VIF at 10. 0.9 r squared is really high, so VIF is really large too. So about 4 or 5. Okay, so if you have an r squared of 0.6, you get 2.5. Okay, so 0.7. So now you're really getting high. So anything over 4 is problematic. So VIF is another tool that we can use to identify multicollinearity. So we already looked at correlation heat map. So this is another way.